Hello everyone, welcome to the Earth Archives. I don't know if you all know that the rotation of the Earth is actually gradually slowing down. Why does the Earth rotate, and what will happen if it stops rotating? Please subscribe to the program before it starts. If possible, please share it with your friends. Please take care of it. Beneath our feet lies a world of wonders, a layered structure that holds secrets about the very nature of our planet. While we traverse the surface, we remain blissfully unaware of the dance taking place deep within the Earth. The core, a realm of iron and nickel, is not static. It spins and rotates at its own pace, separate from the surface we inhabit. As far back as the late 20th century, scientists proposed that the Earth's inner core rotated slightly faster than the surface. This intriguing hypothesis was supported by seismic studies and measurements that suggested a fascinating dynamic. However, in an unexpected twist around 2009, this differential rotation seemed to vanish for a fleeting period. Soon after, the rotation differences re-emerged, but not in the same direction. Surprisingly, it became apparent that the surface was now rotating faster than the core. This shift raised eyebrows and prompted questions. Had the Earth's rotation itself changed? To answer this, scientists turned to various astronomical observations, quickly confirming that our planet's spin remained largely unaltered. Instead, the evidence pointed to a slowing inner core, a kind of braking system engaged deep within the Earth. Researchers revealed that this deceleration is akin to hitting the brakes. The core's rotation had slowed down, matching the surface speed. The difference in rotation had disappeared, leaving the inner core nearly at rest relative to the crust. Yet this was not the end of the story. The slowdown continued, like a car gradually coming to a halt, hinting at more profound changes within the Earth. The first hints of the core's rotational fluctuations came in 1996, when geophysicists at Columbia University, analyzing seismic waves, detected irregularities in the inner core's speed. This finding laid the groundwork for a greater understanding of our planet's heart. Fast forward to last month, a pivotal study published in Nature consolidated data from over 30 years, including 121 seismic events and various nuclear tests, concluding that before 2009, the core indeed spun faster than the surface, but post-2009, the reverse was true. These findings brought forth critical questions. Is this slowing down normal? What implications does it hold for life on Earth? Humans exist atop a solid crust, mere kilometers above a vast mantle, an ocean of semi-solid rock that comprises about 70% of Earth's mass. Below this lies the inner core, a dense sphere of iron and nickel with its own layered structure. The outer layer is fluid, forming what scientists believe generates Earth's magnetic field through dynamic electric currents within molten metals. As we dive deeper, the materials gradually solidify, revealing a solid metallic sphere slightly smaller than the Moon. This core is akin to Earth's heartbeat, spinning independently of the mantle, yet influenced by its colossal mass. The mantle exerts gravitational forces that shape the dynamics of the inner core's rotation, creating a captivating interplay of forces. The ongoing deceleration of the core, while intriguing, aligns with natural phenomena. The core's rotational speed fluctuates over roughly 70-year cycles, reflecting an intrinsic rhythm of Earth's internal processes. This gradual change can even elucidate some variations observed in Earth's magnetic field and its rotation, albeit with minimal impact on daily human life. In the cosmos, a parallel story unfolds among the remnants of massive stars, neutron stars, which inherit their parent star's angular momentum. These compact entities are extraordinarily dense, with radii barely a few kilometers, spinning rapidly, sometimes completing a rotation in mere milliseconds. Despite this, researchers recently stumbled upon a neutron star with a rotation period of 3,325 seconds, equivalent to almost 54 minutes. This discovery left astronomers puzzled. Was this an ordinary neutron star or something entirely different? The discovery traces back to 2002, when the Australian Square Kilometre Array telescope observed peculiar gamma-ray bursts, revealing periodic signals that suggested a neutron star. Yet the extended pulse period challenged conventional understanding. Notably, the signals exhibited three distinct modes: a strong pulse mode, a weak pulse mode, and a quiescent mode, indicating some unknown physical transformation within the star. The conundrum sparked speculation about its true identity. Could it be a unique white dwarf star, larger in size and inherently slower in rotation? However, multiple observations and characteristics indicated its similarity to neutron stars, ruling out the possibility of it being a white dwarf. As scientists continue to unravel this mystery, they suspect that the presence of a strong magnetic field, along with interactions with surrounding materials, may play a critical role in the star's behavior. When the Earth stopped, a new chapter for humanity. Imagine a world where the Earth ceases its rotation, spinning only around the Sun. In this stark reality, the very concept of day and night vanishes. The side facing the Sun basks in an eternal blaze of light, while the shadowed hemisphere descends into an endless abyss of darkness. This stark dichotomy creates an environment where life as we know it would struggle to survive, pushing the limits of endurance for both flora and fauna. As the Earth remains fixed, the temperature on the sunlit side would soar, eventually exceeding 100 degrees Celsius. Plants, unable to withstand such relentless heat and direct sunlight, would wither and die, creating a desolate landscape. For humanity, survival would necessitate an arsenal of cooling technologies to combat the sweltering conditions, turning cities into fortresses against the inferno. In this new world, the sudden halt of Earth's rotation would unleash a catastrophic chain of events. The inertia of a spinning planet would cause violent upheavals in the crust, leading to massive earthquakes. The oceans, previously calm, would respond to this turmoil by generating monstrous tsunamis that ravage coastal regions, only to retreat and rush back towards the poles where gravitational forces are strongest. The devastating impact of tsunamis. Consider the unrelenting force of these tsunamis. They would not only demolish human settlements, but also disrupt the fragile ecosystems along the coasts. With every surge, entire cities would be engulfed, leaving only destruction in their wake. The subsequent retraction of water would expose the ocean floor, creating a haunting graveyard of marine life caught in the deluge. Yet this is merely the beginning of our woes. As the moon's gravitational influence interacts with the halted Earth, its proximity would increase dramatically. A catastrophic collision between the Earth and its satellite would become an imminent threat, signaling the end of all life on the planet. The tides, which have ebbed and flowed under the moon's gravitational pull, would be rendered chaotic and destructive, further compounding the disaster. Life in eternal darkness. Meanwhile, the dark side of the planet faces an entirely different plight. The absence of sunlight would lead to plummeting temperatures, eventually reaching several degrees below zero. Here, survival becomes a test of innovation and resilience. Humans might rely on advanced technologies to provide warmth, yet the flora that relies on photosynthesis would perish. Without vegetation, herbivores would quickly deplete their food sources, leading to widespread starvation. The subsequent death of these herbivores would send shockwaves through the food chain, resulting in the extinction of carnivores that depend on them. This ecological collapse would create a barren wasteland, a stark reminder of the delicate balance that sustains life on Earth. The loss of biodiversity would echo through the remnants of nature, leaving a planet devoid of its once vibrant ecosystems. The disappearance of Earth's magnetic shield. As if this weren't enough, the cessation of the Earth's rotation would also lead to the collapse of its magnetic field, which serves as a shield against cosmic radiation. Without this protective barrier, the planet would become vulnerable to the myriad dangers that lurk in the cosmos. High-energy particles and harmful rays would bombard the surface, compounding the challenges for any surviving organisms. Those few that managed to endure the harsh environment would soon find themselves besieged by the relentless onslaught of radiation. These catastrophic transformations are grounded in the premise that humanity might somehow endure in the aftermath. However, the moment the Earth stops spinning, the impact on human civilization would be more catastrophic than one could imagine. The very fabric of our existence would unravel, thrusting us into a struggle for survival amidst chaos. The immediate aftermath of stagnation. The moment Earth halts its rotation, the effects would be instantaneous and devastating. Imagine being propelled eastward at an astonishing 450 meters per second. This is the speed at which you would find yourself hurtling through the air as the atmosphere continues its relentless motion. The winds generated in this scenario would reach an unfathomable speed of 1,600 kilometers per hour, unleashing a ferocity unseen in human history. In 1925, a tornado in the United States was recorded at a speed of 96.6 kilometers per hour. But this would pale in comparison to the winds created by a stationary Earth. The equatorial region, in particular, would experience winds exceeding 1,700 kilometers per hour, reducing structures to rubble and scattering debris across the landscape. The ruins of civilization. As the winds rage on, the destruction would be total. Skyscrapers, bridges, and entire cities would crumble, swept away as if they were mere grains of sand. The ground beneath would tremble as tectonic plates clash and split, creating deep fissures that swallow anything in their path. Volcanoes, long dormant, would awaken with a fury, spewing ash and lava across the landscape. The polar ice caps would fracture and melt, contributing to tsunamis that rise thousands of meters, further flooding the already devastated land. The relentless winds would also generate intense heat through friction, transforming the atmosphere into a sweltering cauldron. Oceans would begin to vaporize, releasing immense plumes of steam into the air. The planet, once a cradle of life, would become a scorched wasteland, posing an existential threat to any remnants of humanity that might survive the initial chaos. The final struggle for survival. In this nightmarish scenario, the question arises, could humanity ever find a way to survive? The answer is uncertain. As the world becomes a realm of extremes, the possibilities for life dwindle. The few remaining survivors would be forced to adapt to unimaginable conditions, facing challenges that test the limits of human ingenuity and resilience. Amidst the ruins, pockets of life might persist, hidden away from the devastation. Yet, as the atmosphere continues to heat and cosmic rays penetrate deeper, the chances of survival grow slimmer by the day. The struggle against nature's wrath would be relentless, a battle against overwhelming odds that few would likely win. Conclusion: a cautionary tale. The scenario of a world where the Earth stops spinning serves as a cautionary tale, urging us to appreciate the delicate balance of our planet. The intricate systems that sustain life are interconnected in ways we may not fully understand. As we navigate the challenges of today, from climate change to environmental degradation, it's crucial to recognize the fragility of our existence. In contemplating this apocalyptic future, we are reminded of the importance of stewardship over our planet. We must take action to protect our world, ensuring that the nightmare of a stationary Earth remains firmly in the realm of fiction rather than a catastrophic reality. Our fate depends on our choices today, as we strive to maintain the dynamic equilibrium that allows life to flourish on this blue planet we call home.